Hi, everyone. We're going to continue where we stopped the previous lecture. So we talked about the issues with some of the charts. For example, we talked about how the bar charts actually is one of the best charts when it comes to precise quantitative comparison. However, there were some issues with the spaces or the distance between the bars sometimes, and how it can be improved sometimes. And we also talked about some of the issues with the lollipop chart in the previous lecture. So today we are going to continue with some of the problems with the scales. And let's look at some examples and see how we can improve and mitigate those issues of scaling. So this is a chart that you might remember from the first day of classes when we talked about the use of color, and when it was 19, we say 19 days is too long for inspection, right? And we used the red color here in that chart. So this chart is about power plants. So we have different power plants, and we have a bar representing their output in kilowatts, and also what was their target in a target uh, line, right? So now, if you notice that we are using different scales for each of the power plants, and you notice that this power plant, the first one, is producing more than 400,000 kilowatt in comparison to this next one, which producing only 3,900 kilowatt. So we are not basing them on the same scale, and that's why we have different different sizes of the bars. So to look at it closer, you notice that actually the the magnitude, we are not using the same all data as a base for our graphs here, and that's why you notice that we have the bar chart here for the first power plant is smaller in comparison to the next one, which is the 86%. And the reason is because we don't have the same base data or the same scale. So now when we try to use the same base scale, this is how it will look like. Now you can see that the two major producing power plants are basically overtaking the chart, right? And the other ones, they are almost useless because all we can see is the bar chart and they are almost zero, right? So this is not helpful. So we need to find a way how we can show the magnitude and also show whether each plant is meeting its target or not. So this is a very nice graph to mitigate that issue. So we are using a percentage instead of each plant, power plant, and we are using this as a KPI, key performance indicator, for a manager to see whether they are meeting their target or not, right? As a key performance indicator, right? So now we notice that, unfortunately, with the major plants that are producing the most kilowatts, we don't even notice them. We don't recognize them right away, right? So we need to improve this graph to show the magnitude of those two highly producing power plants. So this is how to mitigate it, to use 100% as the target for all power plants, and then use the percentage, and we use the magnitude represented in the size of the circle. So this is a beautiful way to represent that data, where we are showing whether they are meeting the target or not, and at the same time, we are showing the magnitude of production of that power plant. So let's have a look at another example from Kroger. Kroger is the third largest retailer after Walmart and Costco, and they have been actually posting those graphs in their website until recent years. And as you can see, this graph has some issues. And I want you to pause and think about some of the issues that you can notice based on what we have talked about a lot lately. So, some of you might say, well, the colors here, they are not matching, which is true. The grid lines, they are darkened, they need to be muted, right? Which is true. Some of you might say the tilted text here for labels, they should not be tilted, which is I totally agree with that. So here in this graph, it is representing the sales. So they say growth, but they should say sales instead to be very accurate. So the sales started in 2006 by $6.5 billion. And in 2011, their sales increased to 7.3, right? That's the blue bars representing the sales. The red line is representing the number of pharmacies. So you can see that the number of pharmacies increased in 2007 and then in 2008, and then it started to decrease until 2011. However, we can see that there is an increase in sales in 2011. And we want to explain this. Later on, we are going to say, well, to see why this has been an increased trend of sales, although they have been reducing the number of pharmacies in their Kroger stores. So the major issue in this graph is actually they are not starting from zero, right? The scales or the y-axis doesn't start from zero. And that's why you notice that this bar for 2007 in comparison to 2009, and the difference here is 0.4, and it's almost double the size. This guy or this bar is almost double the size of this bar, which is inaccurate and it is deceiving, right? The same thing for 2011. Here, it seems to be it's like triple or 3 times the size of the bar in 2007 and 2006. So that's why we need to start from zero, right? The same thing here, it needs to start from zero because we have a dual axis in this graph. So let's look at another graph here that also was published Kruger. So this graph now, it is showing us in the blue bars the number of pharmacies, the green bar showing us the number of Kroger stores, and the red line is showing us the number of pharmacies percentage in terms of stores, right? So the number of pharmacies divided by the number of stores. And you can see that there has been a growth in the number of pharmacies in comparison to stores. And again, now they fixed the problem here, starting from zero, which is great. On the other hand, here we are not starting from zero, so that needs to be, should have been fixed. So now let's move on and see the next graph. If we notice that the number actually of stores have been decreasing. So in 2007, for example, we had 1,964, and then it increased in 2008, and then it went down to 1,948 in 2011. So the same thing for stores. They were a higher number, and then they went down to also in 2011. So we can see that there is a decrease in the growth in terms of the number of pharmacies and the number of stores. So let's show this. Since we have time series, why don't we show it in a line graph? And this is beautifully done. So the number of stores here, we can see them, and we don't need to start from, as you can see here now, the line chart is showing us the trend line. And we can see that there has been a decrease and continuous decrease in the number of Kroger stores. As for the number of pharmacies, there has been an increase in 2008, and then has been decreased since then until 2011. So now we can see that there has been a decrease in both the number of pharmacies and the number of Kroger stores. However, in the first chart, we noticed that there was an increase in their sales from 6.5 to $7.3 billion, right? So how can we explain that, right? How can we explain the growth of sales, although the number of pharmacies and the number of stores are decreasing? So one way to explain that is actually they have been reducing the number of stores that don't have pharmacies. So that's why when you reduce those stores that they don't have pharmacies, so the number of pharmacies divided by the number of stores will go up. And that's why we have this trajectory that is increasing in terms of pharmacies divided by the number of stores, right? At the same time, their sales have been increasing because they were efficient in reducing costs. So keep that in mind. And that's basically why, although they have been decreasing the number of stores, the number of pharmacies, but their sales have been increasing from 6.5 to $7.3 billion because they have been reducing costs. So again here, what is the real message from those graphs? So from 2007, 2010, Kroger closed stores that don't have pharmacies, which is why there has been an increase in the percentage of stores with pharmacy, right? So second is Kroger has increased the pharmacy sales from 6.5 billion to 7.3 billion with fewer stores and fewer pharmacies. So they actually, those graphs, they missed a very important message or story, which is that there has been a 12% increase in sales with lower costs because of lowering the cost. So just for fun, in those graphs that we're going to go over OkCupid, this is a company that provides dating services, so collects ages from individuals who are interested in dating, and they ask them about the range of, for example, for males, they ask them about the range of ages of the females that they are interested in dating, and the same thing they ask females what are the ranges of of ages of those that they are interested in dating. So let's start by looking at how female match preference change with age. So as you can see here, the dotted line is the age of the individuals or of the females. And the bars or the lines in yellow here represent the range of the allowable age or the range of the age of the males that they prefer to date. So as you can see here, there is a trend for female, they prefer to date those males who are older than them until it gets to an older age where they almost half, right? So they prefer to date those who are older than them, and they are willing to date those who are younger than them. But in the early ages, they prefer those males who are older than them. So also this website has been, which is OkCupid, it was actually developed by mathematicians. And also they collected data about the messages so from the system. So females, who do they message a lot, and also males, who do they message a lot within the system. So now let's look at their messaging, if it really sticks to what they have mentioned that they prefer in terms of range of the age of the males that they are interested in dating. So you can see here they stick to their preference. And the green means that there has been high messages. So they stick to messaging those who are older than them in the early ages. And then as they grow older, you can see that it widens, or that range increases, and it is more uh, into the lower part. So for example, here, 48 years old women would prefer or would message someone who is 34-year-old male, right? So this just tells us some interesting story, and see how beautifully those graphs have been designed to tell those messages and tell us those stories. So now let's look at the male side. So for males, they prefer, from this one, they are the dotted lines, or the dots here. That's their age and the range where they prefer to date. As you can see here with males, they prefer to date those who are younger, females who are younger than them. And as the time goes on and they get older, they prefer even younger females for dating, right? So now let's see if they really stick to the messaging to this range or not. So when it comes to messaging, again, they stick to the range in the early ages here. But as the time goes on and they get older, they actually they send messages to even much younger female. So for example, this 48 years old male is messaging a girl that is around 24-year-old, right? Or a female that is 24-year-old. So this graph tells us a lot, and those are great representations of data. So now let's look at another aspect of data that has been collected by OkCupid, which is Don't Be Ugly by accident. So they have collected in this data set that we are going to see almost 500,000 examples of users' pictures. And they collected also the rate, and they asked people to rate their attractiveness of those pictures. And they also used metadata from those pictures. So what time this picture was taken, from what type of camera it was taken, and so on, right? So OkCupid, or actually this one where you ask people to rate attractiveness, this reminds me in the early 2000s when I was my undergrad, there used to be a website called Hot or Not, where we would upload our pictures into that website, and then random people will rate the pictures, and they will give a percentage what this person is from 1 to 10, right? And then they will show you the percentage of if the person is hot or not, right? So just kind of to bring it up. I don't know if it is still there or not, but it was just um, reminding me of that, the attractiveness. So now looking at this graph, as you can see here, there are three types of cameras. So they have the interchangeable lens, the point and shoot, and the phone cameras. So obviously, the interchangeable lens, which use the SLR, they have won. They have won actually the attractiveness game here, or race. So right. So when people take pictures using those interchangeable lens, they tend to be rated highly as attractive in comparison to those who take pictures with their phones. And this data set is a little bit older, so right now, iPhone, Samsung, they have very high quality, high resolution cameras in their phones. So this just applies to that data set at that time, right? So this graph is beautifully done. The only thing, as you might have guessed, is rotated or tilted text. If they can maybe just flip it or rotate it a little bit, then it will be great. So if they can do it like this and rotate the labels, that would be great. But you get the idea. Still, it's beautifully done. So this graph here is showing us the photos and through age. So they show the the photos attractiveness based on those three categories, three types of cameras through age. So as you can see from this graph, we can see that if someone is 32-year-old taking a photo in a phone camera is going to be as attractive as someone who is 45-year-old who took a photo using an interchangeable lens. So in other words, you can say that a phone camera reduces or actually increases your age, or you can say that the interchangeable lens camera will increase your attractiveness with age. So it is helpful. So in other words, don't take photos with phone cameras if you want to be attractive based on this data set. So now also they have collected data whether that photo was taken with a flash versus not a flash. So if you notice here, actually the flash takes away 8 to 10 years from your, it takes away 10 to 8 to 10 years of your attractiveness, right? If you take a photo with a flash, that takes away 8 to 10 years from your attractiveness age, right? So here, so in other words, we should not use flash, although some of us might think a flash might help actually improve the quality of the picture, but it's not based on this data set. So they also collected data about from the metadata of the pictures, when and what time exactly that picture was taken. So now you can see there are certain peaks. So for example, for attractiveness, it seems to be that at 6:30 in the morning, that's the best time, or where people were rated highly attractive when they take their pictures at 6:30 a.m. in the morning. And those who take their pictures around 5 p.m., right? Those are the highly attractive people. I mean, highly attractive uh, times for attractive people, right? To show your picture to be attractive. And then we have also some dips, or when it is the worst time to take pictures in terms of attractiveness, which is around 2 a.m. And then there is another one here at 10 a.m., 10:30 a.m., and also this one, which is around 8 p.m. So let's have a look at also in comparison in this graph, how beautifully it shows that the sun location and also the ranges or the attractiveness of those pictures. So as you can see, the best or the best time to take pictures to be attractive is when the sun is at its horizon. So that's the best time, which is around 5 p.m., 5:30 or 5 p.m., and also here 5:30 or around 6 uh, uh, a.m. So let's see at the exact, look at the exact conclusion from what we have just learned today from those graphs. So what did we learn from OkCupid? So first, take your profile picture with an SLR camera without the flash at 6:30 a.m. or 5 p.m. for your best chance of being considered attractive, right? So this is a beautiful conclusion based on what we have learned from those videos, those charts. So now let's look at this real world example that was taken from Hamilton County in Cincinnati, Ohio. And so Hamilton County employees versus auditor's office. And let's see how they presented this data. And again, I will ask you to pause and see what are the issues with those graphs, right? So, so you might say they are double labeling, right? Which is true. The grid lines, they are dark. They need to be muted. And the years here, they are tilted. Should not be that way. So the major issue, again, it is the scaling. The scale for the y-axis, it doesn't start from 0. The same thing here, it doesn't start from 0, which is very hard to make an accurate comparison between those two groups. So since we have time series here, years, the best way to represent time series is using a line chart so we can see the trend. So now we are also looking at the percentage from the beginning until the end, and what is the percentage in terms of reduction of full-time employees for the red team. And then also we can see that the percentage of reduction in full-time employees for the blue team, right? This is taking those 21 years from 1990 till 2011. So this is great to kind of now to show. However, it would be better if we can create them or create a dual axis or show them in one graph to be exact, right? So that way we can compare them in a better way. So this is how it should look like. We start from when both of them from, well, when they start in 1990, and then the race starts 20 years later, right? So now you can see that the blue team has been reducing its full-time employees all the way since 1990. As for the red team, has been increasing their numbers until 2008, and we all remember what happened in 2008, which was the recession, and that's when they started to lose full-time employees until 2011, right? And that's where we stopped. So this is great representation of the data, right? However, what will be better for us is actually to, or for the head of the Hamilton County to say, well, I was hired just for 4 years ago in 2008. Why should I should be responsible for the reduction of employees for the past 21 years, right? So in other words, why don't we focus on 2008 and on, since that head of Hamilton County was hired during that time, right? So when we slice the data and start actually from 2008, this is how it looks like. And now this is to put it in a chart and start our chart from 2008. Now we can see that those numbers have changed, right? So the blue team now they have reduced their full-time employees. 13% of their full-time employees were reduced in comparison to 23. Now we can actually have more accurate comparison, and it is fairer, right, for the head of Hamilton County. So now let's look at another example here, which must have been created by the blue team, which is the Democrats. So as you can see here in this chart, all presidents are sitting on their bars, that high bars, and they are sitting, except for President Obama. He's trying to push his bar to stand. And in comparison to those bars, the tax rate was 94%, 77%. I can believe that it used to be that high. Now, so it's just showing us the point that the 40% in comparison to what other presidents had should not be an issue. At least that's what the message they want to say, at least the blue team in this graph, right? So now let's see what the red team want to say in this. So this is the red team, which is the Republican, created this one. And they are saying that the top 1%, they are paying 38% of the federal tax income, right? The federal income tax in 2008. And they are saying that the top 10%, they are paying 70% of the federal income tax in 2008, in comparison to the bottom 50%, they are paying only 3% of the federal income tax. So again, there are a lot of things that you can do with numbers and statistics. And there is a very well-known saying that is attributed to different people that says there are three types of lies: lies, damn lies, and statistics. So again, with numbers, with statistics, you can show whatever you want in terms of stories. But for us, we should always stick to our ethical values and make sure that we use numbers in the right way to tell stories in a very ethical way. And that's all that I wanted to cover in this lecture, and I will see you soon. Thank you.